Hello! Yesterday we saw an infinite process that approached something exact. 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... Even though it continued forever, the sum approached 1 perfectly. Today, let's consider something that seems similar, but behaves completely different. Here is a sum that we refer to as the harmonic series. 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus ... Just like yesterday, the terms keep getting smaller. And because of that, it is tempting to think this sum should also settle down to some finite number. But it doesn't. Even though the terms shrink, they do not shrink fast enough. And as we keep adding more and more terms, the total continues to grow. Slowly. Very slowly. But it never settles. It keeps increasing without bound. To infinity. The infinite sum from yesterday and today look almost the same. In both examples, we keep adding forever, the terms get smaller, and the process never ends. What I find interesting is one infinite sum approaches a finite number, 1, and the other grows not only to 2 or 3 or even 100, but without bound. In mathematics, we say the first series converges and the second diverges. A small change in the pattern creates a completely different outcome. But the part I find most interesting is that this sum grows unbelievably slowly. To reach a total of 2 only requires 4 terms. To reach 3 requires 11 terms. To reach 4 takes 31 terms. Already, the slowdown is evident, but then it becomes dramatic. To reach 10 requires more than 12,000 terms. And to reach 100, well, that requires an unimaginably enormous number of terms. At every stage, it feels like the sum is barely moving. You might think, surely, eventually, it must level off. But it never does. No matter how large a number you choose, this sum will eventually grow larger than that number. Now, my intuition is this seems impossible. But infinity has a different ending, which makes infinity feel even stranger. This is not merely something mathematicians suspect to be true. In mathematics, we can actually prove it with certainty. No matter what positive number we imagine, this infinite sum will eventually surpass it, even though the number of terms required may itself feel beyond imagination. Well, if you want to understand why the harmonic series continues without bound, you can read my article called A Log That Is Natural. It's on my Lazarus Math series at intersectingus.com. Okay, tomorrow we'll take a different perspective on infinity to see where it appears in surprising places.